Differences between random effect model and fixed effect model. Random effect model versus fixed effect model. In statistics, a random effects model is a statistical model where the model parameters are random variables, whereas in statistics, a fixed effects model is a statistical model in which the model parameters are fixed or non-random quantities. Synonym of random effect model is variance components model, whereas synonym of fixed effect model is least squares dummy variables (LSDV) approach. Covariance of random effect model is equal to 0, whereas covariance of fixed effect model does not equal to 0. No correlation between error term and x in random effect model, whereas correlation between error term and x in fixed effect model. Data type of random effect model is panel data, whereas data type of fixed effect model is also panel data. Functional form of random effect model and fixed effect model are given for comparison. Effect type of random effect model is random effect generalized linear regression (GLS) regression, whereas effect type of fixed effect model is fixed effect within regression. Estimator beta cap random effect is consistent and efficient under H0, not under HA. Whereas estimator beta cap fixed effect is consistent under H0, but not under HA. Null hypothesis of Hausman test is random effect model is used. Whereas alternative hypothesis of Hausman test is fixed effect model is used. Decision in random effect model is based on p-value of Wald chi-square test, whereas decision in fixed effect model is based on p-value of f-test. Intercept of random effect model is constant, whereas intercept of fixed effect model is varying across groups and times. Slopes of random effect model is constant, whereas intercept of fixed effect model is constant. Error variance of random effect model is varying across groups and times, whereas error variance of fixed effect model is constant. Estimation in random effect model are generalized linear regression (GLS) and feasible generalized linear regression (FGLS), whereas estimation in fixed effect model is least squares dummy variables (LSDV). Decision made in random effect model is based on p-value of Wald chi-square test, whereas decision made in random effect model is based on p-value of f-test statistic. P-value range in random effect model is p-value greater than 5%, whereas p-value range in fixed effect model is p-value less than 5%. If p-value greater than 5%, results are statistically insignificant at 5%. Whereas alternative hypothesis under Hausman test will be rejected. If p-value is less than 5%, then null hypothesis under Hausman test will be rejected, whereas if p-value is less than 5%, then results are statistically significant at 5%. Static commands of random effect model and fixed effect model are given. Null hypothesis of Hausman test is accepted mean that when the random effect model are used properly gives the best linear unbiased estimates, blue, which mean null hypothesis of Hausman test is accepted because they are consistent, efficient and unbiased. And also p-value is greater than 5% level of significance. Whereas, alternative hypothesis of Hausman test is rejected and it's still consistent and inefficient, because p-value is greater than 5% level of significance. Alternative hypothesis of Hausman test is accepted, which mean that null hypothesis of Hausman test is rejected, because when we accept alternative hypothesis of Hausman test, then there is correlation between the error term and x. Its estimates would be inconsistent, and also p-value is less than 5% level of significance. Whereas, when the fixed effect model are used properly gives the best linear unbiased estimates, blue, which mean alternative hypothesis of Hausmann test is accepted because they are consistent, efficient and unbiased, and also p-value is less than 5% level of significance. Assumptions of random effect model are 5, such as the model is correct, full rank, exogeneity, homoscedasticity and normal distribution of disturbance UIT, whereas assumptions of fixed effect model are 6, such as the model is correct, full rank, heterogeneity, homoscedasticity, no cross-section or time series correlation, and normal distribution of disturbance EIT. Kindly subscribe my YouTube channel Thesis Helper. Thanks for watching.